Here we have a scenario exactly like the lab we did in class. We have these two masses. And they are held together by a compressed spring. There's a string tying them together that will be cut. So which one do we want to know are true about the motion of the blocks immediately after the string is cut? And we're looking for two answers. So this we recognize right off the bat as a law of conservation of momentum. So P0 equals P. The initial momentum is 0. So the momentum of the system at every moment in time afterward must be 0. So the first option is talking about the center of mass. So the center of mass, if this is our mathematical center, we can see that it'll be that'll be our center of mass. That center of mass has a velocity of 0. So afterward, it's going to have a velocity of 0. The system can be represented by a point located at the center of mass. And if the center of mass has 0 momentum before, it will have 0 momentum afterward. So choice A is one of the correct answers, and which is diametrically opposed to the second one, which is it goes to the right. The magnitude of the acceleration of the left block is equal to that of the right block. Well, F net equals ma, and the acceleration is the net force divided by the mass. What we know is that the forces are equal and opposite to each other. So if the forces are equal and opposite to each other, and the accelerations are different, then the masses are different, then the accelerations will be different. So they can't possibly be equal to each other. And since m is the smaller mass, it will have a greater acceleration. Choice D.